Like, you shouldn't be able to see my hands type of close. Here we have the 5th cervical vertebrae model. I know this is a cervical vertebrae. 1, because of the bifid tip on the spinous process. 2, we have transverse foramen through which the vertebral arteries and veins descend down the first part of the vertebral column. As we enter this intervertebral zone, we're going to pass into first this adipose-filled epidural space. Maybe that sounds familiar because it is here within the epidural space that individuals can receive a localized neural block in the case of things like fentanyl citrate, so that no sensations make it anterior or superior to the site of that injection. As we pass through the epidural space, we will encounter the outermost protective layer known as the dura mater, or tough mother, separated from the underlying arachnoid mater by this subdural sinus or subdural space. Passing the arachnoid mater, we come into this large void surrounding the spinal cord known as the subarachnoid space, through which cerebral spinal fluid flows, as well as through the central canal of the spinal cord itself. Back to the outside of the spinal cord, we have the 3rd innermost protective layer, the pia mater. When looking at the spinal cord, we'll find a posterior median sulcus and an anterior median fissure acting as landmarks separating the left and right halves of the spinal cord. Extending off of the spinal cord, we're going to have dorsal spinal roots and ventral spinal roots. These roots give rise to the ventral and dorsal root, the latter of which has this dorsal root ganglion, which houses sensory cell bodies, also known as soma. Coming back to the spinal cord itself, we find anterior white tracts, lateral white tracts, and posterior white tracts. We are going to find gray matter internal to that. When we look at the 2 halves of the gray matter inside the spinal cord, we find them separated into posterior gray horns, lateral gray horns, and anterior gray horns. Posterior gray horns, we have the cell bodies that receive sensory information from all over the body. The lateral is home to primarily visceral motor neuronal cell bodies, and the anterior gray horn, somatic motor cell bodies. The left and right, or right and left, halves of the gray matter are joined at the small branches of gray matter known as commissures. We have an anterior gray commissure, central canal, and a posterior gray commissure, allowing neurons area for crossing over from one side to the other. We find posterior and anterior white commissures as well, but not frequently talked about as much in this anatomy class. This spinal cord is suspended right throughout the vertebral canal, housed and protected by this neural or vertebral arch. We also have deep inside here, really hard to see, denticulate ligaments that help keep this suspended in the middle and avoid jarring side-to-side motion due to impact. Once we head out of the central nervous system through the intervertebral foramen, this now mixed spinal nerve is going to split into a dorsal ramus servicing the posterior wall of the body, a ventral ramus servicing the anterior lateral wall of the body, as well as the rami communicantes. Here we see the gray ramus. What we don't see is the white ramus. Our way into what's known as the sympathetic chain of ganglia. That is the fifth cervical vertebrae model.